Guys, welcome to YouTube channel Foundation JEE. Today's lecture is on work. Guys, in this lecture we will first see how the work is differ in our general life and definition of work in physics. Okay, then we will see the definition of work and see different cases when an external force is applied on object, then how the work is being calculated. Okay, and for your better understanding I have also chosen some numerical problem which we discuss in this lecture. Okay, so guys, first of all see one thing. Suppose this one is a person. Okay, now there is a fruit basket on his head. Okay, now so guys, suppose he starts his journey say point A and goes to market. Okay, and suppose here and again he return back to the same point. Okay, so guys, whether we can say the person has done any work when he is moving from say this point A or this point B, a market. So guys, in physics we can say there is no work. Why? Because in definition of work there are two things important. Okay, the first one is guys, a force should be acting on object, and second one, the displacement of object must be in direction or opposite direction of force. Okay, so see guys, the person is moving here to here with a basket of fruit on his head. Okay, now suppose he sell down something. Okay, again when he return back to this position. Okay, so what's happened guys, the net displacement here is 0. So here what is missing? Displacement okay, is missing, okay, which is 0. Okay, so displacement must be required for work on object. Okay, so guys, we can also define the definition here. Work on object is equal to force into displacement and cos theta, okay, where theta is angle between force and displacement. Okay, so guys, now see the first case of work on object when force is applied on object and displacement in same direction. So displacement of an object in direction of force. Okay, so suppose here this one is a block, okay, on ground. Okay, now suppose one person is pushing with a force F, say this is constant. Okay, now suppose in this direction the object move at this point, and you can say sir displacement equal to say d. Okay, so what we say in this case, work done equal to F into D and cos theta. See guys, if the person is pushing here and direction of force is in this direction and displacement D is in same direction, then what you see here, the cos 0 equal to 1, because when two lines are parallel to each other, then we say angle is 0, so theta equal to 0. Okay, so guys, work done in this case equal to FD. Okay, now see, as per definition, displacement of object be in direction or opposite direction of force. So here displacement is occurring where? In direction of force. Okay, now see the second case. Here displacement of an object opposite to force acting on object. Okay, so guys, suppose here this one is a ball, say its mass is m. Okay, now we throw this ball in vertical direction. Okay, so now it attains its maximum height h. Okay, so what will be the work done by gravity on this ball? See, I am using the word gravity. Okay, so you know gravity here, when we are talking, then this one is a earth. Okay, or you are throwing this one from here to here, so one force due to gravity is acting, we know, which is weight of the object. Okay, so see guys, what's happened here, the force is acting in down direction and movement of ball in up direction. Okay, so when we say work done on object due to gravity, so we apply the formula here, force into d and cos theta. Okay, so if we say here force is acting in down direction, which is weight of the object, now d is here h. Okay, now see, if we say this one is direction of displacement d, or this is here force F, so what will be the angle here to here, so this theta equal to 180 degree. Okay, so cos 180 degree equal to -1, or you can say, sir, work done by gravity is minus m into g on object. So guys, here negative sign indicates work is being done opposite to force. Okay, now the third case. Okay, now suppose displacement of an object perpendicular to force. Okay, so how you can see this one, suppose one bird. Okay, now see, this one. Okay, now see, if the movement of this bird in this direction at certain height, then the gravitational force is acting due to mass of this bird in down direction, so you can say this is mg. Okay, so what will be the work done by gravity on this bird? Okay, so work done by gravity on bird equal to, guys, force into displacement and cos theta. Okay, so see, here movement is in this direction, displacement, so what you say, this angle is, guys, now 90 degree, so you know cos 90 degree equal to 0. Okay, so we can say here work done by gravity on this bird is 0. Now see the Fourth case, displacement of an object on inclined plane. Okay, so guys, suppose this one is a inclined plane, or here one block whose mass m is resting. Okay, now suppose it slides here to here s. Okay, displacement. Okay, so what will be the work done by gravity due to slide from here to here? Okay, suppose this angle is theta. Okay, so work done by gravity, or you can say weight of object when it slides a displacement say s. Okay, so we apply here the formula: work done by weight on object to slide displacement s. So we can write fd cos theta. Okay, so guys, here see the weight of the object is in down direction, which is mg. Okay, now what will be the angle? So if we say this angle is alpha, so what you can say, sir, here if this one is again 90 degree, then alpha equal to 90 minus theta. Okay, so if we put here this one, so f is m into g, or displacement is s, or cos here 90 minus theta. Okay, so mg s is displacement on inclined plane, or this one is sine theta. Okay guys, one thing you notice, when we are calculating here the work done by the gravity when the object slide from here to here, then we ignore the frictional force acting between inclined plane and object is 0. Okay, so when you start solving such type of question, then first thing you notice, the surface is frictionless, or anything is given about friction or not. If it is not saying about anything friction, then you can assume force due to friction is 0. So force due to friction is 0 when surface is smooth. Okay, so guys, you have seen all four condition here. Now one thing we have not discussed till now, what will be the SI unit of work? Okay, so you can say, sir, this one is FD cos theta. Okay, so any case cos theta is a number. Okay, so it will not take part in unit, so we ignore here. Okay, now you know the unit of force is Newton or displacement is meter, so unit of work is Newton meter, or you can say in single word SI unit of work is joule. So other name of unit of work is joule. Okay, so guys, hope now the work done on object due to external force is clear to you. Now next we will see some numerical problem for your better understanding. Okay guys, before going to discuss numerical problem based on work, here see the formula of work. Here work done on object due to external force acting on object equal to force into displacement or cos theta, where theta is angle between displacement of object and force acting on it. Okay guys, in some books you will see work done is equal to, if we say W, then force into displacement. Okay, so what they use for the displacement word here, displacement in direction of force or opposite direction of force. Okay, so what is the displacement of the object along the force, means the in direction of force, or displacement opposite to the force? Here displacement means this one. Okay, so you can solve a question based on work by any method. Okay, this one is also correct or this one is also correct. Okay, see question number 1 here guys. A man pushes a table with constant force 250 Newton and displacement of table in direction of force is 25 centimeter. Then find work done by man on table. Okay, so here solution, guys, if we apply the first one, work done is F into D into cos theta. Okay, so here you can say, sir, we can write force 250 Newton, or you care about the unit of displacement which is in centimeter, so SI unit of displacement is in meter, so we divide it by 100. Okay, here the force 250 Newton, or you can say displacement 25 centimeter in same direction, so angle is 0 degree here. Okay, so this value is 1, guys. So you can say, sir, we can write this one equal to this one, so this becomes, guys, 62.5 Newton meter or 62.5 joule. Okay, so if we apply this one, okay, this formula, so force is, guys, 250 Newton, or the displacement in direction of force is, guys, 25 centimeter, so we can write this one. Finally you can solve this one, so you can also get the same answer. Okay, so guys, you can solve by this method or by this method. Okay, if you remember this method, then what's happened, you don't need to calculate displacement of the object in direction of force or opposite direction of force. Okay, the basic difference. Okay, now see the second question, guys. Question number 2, guys. A man lift a suitcase whose mass is 5 kg and put on a shelf whose height from ground is 1.5 meter. Okay, so find work done by man to lift the suitcase. Okay, so here, guys, solution, here work done, okay, is F into D into cos theta. Okay, guys, here force the person who applied on suitcase is equal and opposite to weight of the suitcase to lift. Okay, so weight of the suitcase is, if here weight of suitcase, here what you say mg, so m is 5 or this is 9.8 or this is in kg, this is meter per second square, so 49 Newton he will apply on suitcase. Okay, now see if this one is suitcase, okay, or the person is applying a force in this direction, up direction, okay, and displacement is also in up direction. So what you say about angle cos of 0 degree equal to 1, so this one becomes 49 Newton, or here displacement 1.5 meter, or this one 1. So you can say, sir, this value will come this one, okay, or 73.5 joule. Okay guys, one thing you also done, solve by the second method, force into displacement, work done. Okay, so see here force is in up direction and displacement is also in same direction, so you can also write here same thing, so you will get this one value is 73.5 joule. Okay, so in any method you can solve, you will get the same result. Okay, now see question number 3 here. 3, boy throw ball mass 100 gram vertically in up direction, okay, with velocity 19.6 meter per second from ground. Okay, now here question is find work done by gravity on ball to reach at maximum height. Okay, so guys, here solution, work done is force into displacement or cos theta. Okay, so here first of all you need to calculate the displacement maximum height, so we use a motion equation, already we discussed in our earlier lecture, v square equal to u square plus 2g and you can say h. Okay, here also you can say v square equal to u square 2as. So what we do here, acceleration value is due to gravity, okay, or s is height. So at maximum height v final velocity equal to guys 0. Okay, so we can put here 0 whole square, u is given 19.6 meter per second whole square, then we put here negative sign. Why? Because here see, ball is going in up direction, however the acceleration G is acting in down direction. So if this direction is positive, then G value acceleration due to gravity is negative, or you can also say it decelerate the ball. Okay, so it will come to zero velocity at maximum height. So this is 2 into 9.8 meter per second square into h. So we can write this one or this one h value, because this is either positive, then divide this one, so this is 19.6 meter. Okay, now see here we are talking about work done by gravity. So gravitational force is acting in down direction or displacement in this direction. So if you apply this one, so what we write here, force equal to, guys, weight of object equal to force due to gravity on object. Okay, so guys we can write here, this one is equal to 100 gram into 9.8 meter per second square, or again in SI unit you have to convert it into kg, or this is 9.8 meter per second square. Okay, so what we say, this value will become 0.98 Newton. Okay, so if we apply all the value here or put all the value, this is 0.98, this one is 19.6, or see here this angle is here to here, you can say sir this is 180 degree. So if you put here cos 180 degree, then this is -1. So you have to make multiplication with -1. So finally you guys get 19.208 joule, or with negative sign. So you can say sir what does mean by here negative sign. So negative sign indicates work done on object due to gravity is opposite to applying force. Okay, so applying force is due to gravity in down direction or motion in up direction. Okay, or you can say work is being done opposite to the force. Okay, now if we solve this one by another method, force into displacement. Okay, so if we say force in this direction is positive, then here displacement in this direction is negative. So again if you not put this one or only you write D, so you have to remember here displacement is opposite to force, so you can put a negative sign. Again you will solve this one, then you will get the same result. Okay, so guys, if you don't want to make a confusion, you just apply this formula. Okay, so you can solve any questions. Okay, now see fourth question. Question number 4, guys. A block mass 2 kg slides on inclined plane, inclination 60°. Find work done by gravity if it slides 30 centimeter, or ignore friction between block and inclined plane. Okay, so guys, here solution, if you see, this one is a inclined plane, or this angle is what, guys? 60°. This block is here, now it slide here to this point, or this is given 30 centimeter. Okay, so here mass mg is acting in this direction. Okay, in down direction. So work done on block due to gravity when it slides 30 centimeter on inclined plane equal to force into displacement, or here cos theta. Okay, so guys, here theta is what? Angle between displacement and force. So this is theta here. Okay, so we can say here F equal to what? M is 2 kg, or G 9.8 meter per second square, or displacement is given in centimeter, so this is in meter now, or here cos theta, cos 60°. Okay, is it correct 60°? No, this is cos 30°. So this will not. Why? Because see, this one is a right angle triangle, this is 90°. So you know sum of the all angles, say A angle B angle C equal to 180°. So if we say this angle is A, okay, or this is B and C, so angle A equal to what? B is say 90°, C is 60°, or this is 180°. So angle A equal to 30°. Okay, so we can write here 2 into 9.8 into 30 by 100 guna or multiplication. This is 30°, so this is root over 3 by 2. Okay, so guys, this value will come 5.09 joule. Okay, now if we apply this one, force into displacement, where displacement is in direction of force. Okay, so here what will be the displacement in this direction? So you can write sine 60° equal to what? This is P, perpendicular distance, or this is hypotenuse H. Okay, so we can also see this one will come P equal to sine 60 degree into here 30 by 100, okay, which is hypotenuse. Okay, so finally what you say, M, this M is coming guys 2 kg. Now the 9.8 meter square force weight of this one. Now displacement D in direction of this one, so you can write here root over 3 by 2 or 30 by 100. Okay, so see the same thing is again coming. Okay, or again you will get the same result. Okay, so what you see, if you apply this one or you remember this formula, then both will give you same result. Okay guys, in my opinion you remember this formula for calculating the work done on object due to external force, because this is simple force into displacement or cos theta, where theta is angle between the force and displacement. Okay, so hope guys now concept of work done on object due to external force is clear to you. In next lecture we will see energy, in which we will discuss kinetic energy and potential energy. Guys, if you think this lecture is informative for you and others, so please like and subscribe this YouTube channel, Foundation JEE channel. And thank you once again for listening and watching this lecture. Guys, if you want to be updated for my next lecture, so please on your YouTube notification. Thank you.